let's start 5-4, direct variation. Direct variation means one, whatever it is, varies directly with something else. So if I had 12 inches, that would be 1 foot. 2 feet would be 24. And 36 would be 3 feet, and so on and so on. That would be a direct relationship. The inches and feet, inches varies directly with feet. So that's just one example. Direct variation, it means an equation can be written in the form y equals kx. And that k stands for a number, any number. It could be a whole number, it could be a negative number, it could be a fraction, it could be a decimal. It just has to be a number. And the k is the constant of variation. That's what it's called. So constant, even though it starts with a c, the variable used in the equation is a k. So y equals kx. If we go back to our example here when I said inches varies directly with feet, if feet is y and inches is x, to get y, I would multiply inches, whatever it is, but I would have to divide it by 12 or multiply it by 1/12. Because if I had 12 as my x, 12 times 1/12 would be 1y. If I said that my x was inches and my y was feet, to get my feet, oops, I did the same thing. If I said inches was y and feet was x, to get y, I would multiply x by 12. The constant would be 1/12, or in this one, for the orange example, the constant k would be 12. Both of them, okay, it just depends which one you put as x and which one you put as y. Either way, it's a direct variation, and your k is a number. In example 1, you're just supposed to determine whether or not it is a direct variation. So we have y equals 4x. Well, y equals kx. So my k is 4, k is a number. Yes, this is a direct variation. In example B, negative 3x plus 5y equals 0. Okay, it's not in the form y equals kx, so I have to manipulate the equation. I have to change it so that it's in that correct format. So I'm going to locate my y. Here it is. I want to isolate y. My first step then is to not divide by 5, but to do the inverse of subtract 3x, which is add 3x to both sides. Negative 3x plus 3x goes away, and I'm left with 5y equals 0 plus 3x is 3x. I still don't have y equals. I need to divide by 5 next. 5 divided by 5 is 1. I'm left with y equals 3x over 5. I can also rewrite the 3 and the 5 right here as a fraction. So it's 3/5 x. Okay, it means exactly the same thing. Now here, y equals, there's my k, there's my number, x. So the answer, is it a direct variation? Yes, it is, because k equals 3/5. And in this example, it's yes because k equals 4. Okay, so here's like the mini part of the answer. The real answer is yes or no. Example C, 3x plus y equals 8. I find y, there it is. Y is not by itself yet. I need to move that 3x. In order to move it, I'm going to do the inverse. So I'm going to subtract 3x. 3x minus 3x goes away. And I have y equals 8 minus 3x. 8's a constant, and 3x, there's that variable here, so I cannot combine them. They are not like terms. This says y equals 8 minus 3x. There is no y equals kx. x. What would the k be? I have two different numbers. Doesn't make any sense. So the answer to this is no, because it doesn't have y equals a number times x. I have this extra 8 in here, and that's the problem. Let's look at example D. Negative 4x plus 3y equals 0. Here's my y. I need to isolate the y. The first thing I'm going to do is to get rid of this negative 4x. So instead of subtracting, I'm going to do the inverse. I'm going to add. Negative 4x plus 4x is 0. It goes away. 3y equals 0 plus 4x is 4x. Next step, divide it by 3. 3 divided by 3 is 1. I'm left with y equals 4x divided by 3, which is the same thing as y equals 4/3 times x. Y equals kx. My k is 4/3. It's okay that it's a fraction. As long as it's a number, it works. So the answer to D, is it a direct variation? Yes, it is. In example 2, you're not given the equation. You're given examples of coordinate pairs, so x and y. And using this information, we have to figure out what the equation is and then decide if it's a direct variation equation. So if I want to get from y to x, how do I get from 6 to 2? How do I get from 2 to 6? Well, y equals, if y is 6 and my x is 2, I need to multiply it by 3, right? So my equation is y equals 3x. Let's see if it works for the other examples, otherwise it's not consistent and then it's not a direct variation. So when y is 12, does that equal 3 times 4? Yes. And if y is 18, is that 3 times 6? Yes, it is. So my equation, y equals 3x, that means k is 3, there's that number. So yes, it's a direct variation. Let's look at a second one. X and y chart again. When x is 1, y is negative 2. When x is 3, y is 0. When x is 7, y is 4. If it was a direct variation, I would have y equals my k, x, where k is just a number. So let's use this first set right here to figure it out. So when y is negative 2 and x is 1, I need to multiply it by, well, 1 times negative 2. So that means my potential equation is y equals negative 2x. Let's see if it works for the other two ordered pairs. When y is 0, x is negative 2 times 3. That does not work. When y is 4, is it negative 2 times 7? No, it's not. So it is not a direct variation. So now that we figured that out, we do need to figure out what the equation is. So let's get rid of this. How do I get from 1 to negative 2, 3 to 0, and 7 to 4? Well, from 3 to 0, we know multiplication isn't going to work. So let's try adding 1 to negative 2. That's going smaller, so let's try subtraction. 1 minus 2, that would be, minus 3. Let's see if it works. Negative 2 equals, does it equal 1 minus 3? Yes, it does. When y is 0, 3 minus 3, that works. Y is 4, is that 7 minus 3? Yes. So my equation is y equals x minus 3. And we can tell from this equation, it's not y equals kx. It's x minus a number, and that means it's not a constant variation. Okay, it's your turn in the Google form, and bring your work to class, please. Do check it out. It's on page 282 to 283, 1A, 1B, 1C, 2A, 2B, 2C. So that's 6 questions. Put the answers in the Google form and then bring all your work to class tomorrow. Thanks everyone. Good night.